You're welcome to Maths Clinic series. In this video, we want to look at the second part of the introduction of logarithms. The previous one, we did the definition of logarithm and want to solve questions involving the definition of logarithms. So, example number 1. We want to write the following in the log form. This is indices. How can we write these indices in the logarithmic form? And so the idea of the definition will be at work over here. Here we are asking the question, how many 7s will I multiply to get 49? And the answer is 2. And so in the log form, I'm going to write log base 7 here of the 49 is equals to the exponent, which is 2. Again, what will you write for 5 to an exponent of -2, which is equals to 1 over 25, and that is true in indices. So how do we relate this to logarithm? You can pause the video and try. I'm sure your answer came as log base 5 1 over 25 is equal to 2, -2. Now let's try more. 10 exponent 0 is 1. How will you write this in a logarithmic form? Beautiful. I'm sure you had log base 10 1 is equal to 0. So the base will always remain base. And then this is the answer when I multiply this one by itself, or this to an exponent of 0. So that becomes the log over here. 23 is equal to 23. Or we can say 23 exponent 1 is equal to 23. How will you put this in the log form? Wow, that is log base 23 is equals to 1. In future, we will learn more about this expression where we have the same base and the same number for the log. Now let's look at example number 2. Find the value of x. This is logarithmic equation. We've not gotten to there yet, but per the definition that we've understood, we can easily solve this equation without any difficulty. Log base 10 into bracket x minus 2 is equals to 2. How will we use the definition to solve this question? So you can try your hand by pausing the video. I'm sure you had s is equals to 51. Good. And this is how you will do it. By using the definition of logarithm, this will come as a number x minus 2, and then the base will move to become base of 7 with an exponent of 2. Then we've taken away the logarithm or the log, now leaving everything in the form of indices. Now this can be written as x minus 2. This is the same as 49, that is 7 times 7, and making x the subject, we have s is equals to 49 plus 2, and that will give us the answer as 51 as we had. Now the next question, we are to find the value of the following logs. So this is log base 381. How do we find the value of log base 381? We are asking a simple question. How many times will I multiply 3 to get 81? You can apply the form of indices or the definition and then apply indices to solve this question. We can assume that log base 381, we don't know the answer. So let's assume the answer is maybe n. Then we apply the definition. And how do we work with the definition? We said the definition will be 81 is equals to the base 3 to an exponent of n, right? So then the log is no longer in place. We are left with indices. Now we can change 81 to 3 exponent 4, which is equal to 3 exponent n. And in indices, we learned that if we have indices with an equal sign where the bases are the same, we equate exponent. Therefore, we can say n is equals to 4. So when that happens, then we can say log base 381 is equals to 4. As simple as that. log base 381 is equals to 4. So what will happen to the value of log base 2 0.25? Remember, we are not using calculator for this, so don't point calculator for it. We want to apply the definition of logarithm in understanding how to find log without using calculators. So you can pause the video and try to find the value of log base 2 0.25. I'm sure here too you had the answer to be -2. How did it happen? You can just write once again log base 2 0.25 to be equal to something we don't know. We don't know the answer, so we want to let it be like x. Now, per the definition, 0.25 will be equal to 2 to an exponent of the x. All right. Again, we can change 0.25 to a fraction, and that will give us 1/4 is equal to 2 exponent x. And 1/4 is the same as 2 exponent -2, which is equal to 2 exponent the x. Why are we saying that? 1/4 can be written as 4 exponent -1. And changing 4 to an indices, or to indices, will give us 2 exponent 2 times the -1 existing already. And so we get 2 to the power -2. And since the bases are the same, we equate exponent and say s is equals to -2, which means everything here will give us -2. Good. Now try for the value of log base 5 0.008, and let's see the result. Pause the video and try it. Good. I'm sure you also had your answer to be -3, and it's very simple. We assume this one to be a letter we don't know. We change this one as 0.008 is equals to the base 5 to an exponent a. Then this can be converted into fraction, which is the same as 8/1000, right? Because we can move the decimal point 1, 2, 3, and that will give us 8/1000. And writing 8/1000 to the lowest form will give you 1/125, right? And 1/125 can be written as 125 to an exponent of -1, which will give us 5 to the power a. Then again, we can convert 125 as 5 and exponent of 3, which will multiply the -1 to give us -3, and this will give us 5 exponent a. Since the bases are the same, we now equate exponent and say a is equals to -3. So therefore, log base 5 0.008 is equals to -3. Now you can try this last question, log base 4 into bracket 1/256, and see the result. I'm sure you did it and you had -4. So try it and get a -4. So with this, we come to the end of second part of the introduction to logarithm. The next video, we are going to look at the definition, the laws of logarithm. Remember, I told you that we are going to have 3 different keys. The key number 1 is what we've been able to accomplish in these 2 videos. The next video, we are going to look at the laws of logarithm. Thanks so much for watching.